Hello ladies and gentlemen, welcome to this week's video called the Kinetic Molecular Theory, or the theory of why when you sneeze it gets everywhere. I'm Mr. Lee and I have a cold. So, if we take a look at this little image here, we see blue and red dots just bouncing around everywhere. This is what we call our molecules, which brings us to what is kinetic molecular theory? It is the theory that states that matter is made up of particles. Every single thing in this universe is made up of particles. Particles are always moving, and the motion is dependent on temperature. So if we have a change in temperature, the motion of these molecules will either increase or decrease based off of their kinetic energy. Now you might be asking, what is kinetic energy? Well, kinetic energy is the energy of movement. The more energy you have, the more kinetic energy you have. The more kinetic energy you have, the more you'll move. So here we have a stock image of ice water. Here we have multiple different states of water. We have the solid, which is represented as the ice. We have the liquid, which is the water. And we have the gas, the evaporation that could be taking place right above the surface of the liquid and the air. Let's take a look at each of these in depth. Solids. Here we have an image of a solid, and your eyes aren't tricking you. The blue dots are ever so slightly vibrating. And that's what's happening if you take a look at all solids on a molecular level. We're constantly moving. Everything in this universe has motion. So on a molecular level, everything is vibrating. The molecules are attracted or repelled to each other. And that's what causes these vibrating motion. This is what we call the intermolecular forces. Solids have a definite shape and a definite volume. This is very unique to solids. Now, if you are a comic book fan like I am, this might sound a little bit familiar. Here we have the superhero, the Flash, the fastest man on Earth. Now, in this comic strip, we can see that the Flash can vibrate through solid objects. In this case, this is a brick wall. And here, we have the Flash explaining to Supergirl how he does it. He says that he can vibrate his molecules at such a rate so that he can actually pass through solid objects. How cool. He even teaches Supergirl how to avoid physical contact by trying to punch her. Wow, what a jerk. The next thing we have are liquids. Now, liquids here, we can say on a molecular level that liquids are constantly moving as well, just like every single thing in this universe. But the motion is random, keyword random, and we'll be seeing that word a lot during this unit. The more motion something has, the more energy it has, and that's why liquids are able to flow past each other, because all those molecules have more energy, so they can slide all over each other. Liquids do not have a definite shape. We call that an indefinite shape. That's why when you put a liquid in a container, the liquid shape is the container's shape. Wow. Liquids have a definite volume. What that means is if we pour a liquid into a graduated cylinder or any measuring device, we can measure the volume of the liquid. And here we can see the image of liquids, molecules just vibrating all over each other. That sounds wrong. Next thing we have are gases. Now, gases. This unit will be focusing mainly on gases, so pay attention. Gases, they are vibrating all over each other. Gosh, I gotta stop saying that. Gases, the attractive forces, really have no effect on each other. The intermolecular forces don't really bother them. So what they do is they just collide and they bounce off of each other. They move randomly. Once again, the keyword randomly. They move very quickly. And if you have a gas and you put it into a container, we can say that it has an indefinite shape and volume, meaning we know that the gas is in that container, but it's all over the place. We don't know exactly where it is. Okay, same with the shape. We know that if we put gas inside of a container, it takes the shape of the container, but at any second, it could change. Now, this brings me to my favorite joke at the end of our lesson. Here we have two old people. We'll call them Harold and Gertrude. One day, Harold and Gertrude were at church, and it was the middle of the service. Gertrude lets out a really loud fart, like this. Gertrude then leans over to Harold and says, "Harold, I just let out a long, silent fart." No one caught me. So Harold leans over and says, "Gertrude, you need to get your hearing aid checked." Ah! So let's wrap this up. All molecules move. More kinetic energy means there's more motion. Energy of a molecule is determined in the object state of matter. Solids have low amount of energy. low amount of kinetic energy. Therefore, there is minimal amount of motion. Yet, there is still motion. Liquids have a medium amount of energy, enough energy for the liquid to move around. Gases, they have high energy. They have a lot of energy, enough energy so that they're just bouncing all around all over the place. So, ladies and gentlemen, this brings us to our very first point of sneezing. When you sneeze, there's tons of energy in the molecules. And so when you sneeze, the germs go around everywhere because there's a lot of motion.